Hello there, and welcome to the Sleepy Space Channel. The most famous habitable planet ever found may have no surface to stand on at all. Kepler-22b was celebrated as a second Earth, a temperate world circling a golden star 600 light-years away. Yet we have never once managed to weigh it, and inside that missing number hide three possible planets: a rocky giant whose gravity would crush you beneath a sky no rocket could ever leave, a shoreless ocean sealed over a floor of hot ice with nothing living to eat in it, and a small Neptune that is nothing but sky, thickening down into darkness forever. Tonight we open all three doors, slowly, and learn why every version of this gentle-sounding world is harder to live on than anyone hoped. If you find these explorations worth your time, a like or a subscribe helps the channel reach others who do. Thank you for being here. But none of this is something you need to carry. Kepler-22b has kept its secret for 600 years of light, and it will keep it through the night. Settle in. Let your shoulders soften. Let your breathing slow. Let the day fade away. Let's begin. Part 1. The second Earth that wasn't. There is a planet 600 light-years from here that was once the most famous world outside our solar system. Its name sounds like a catalogue entry, because that is exactly what it is. Kepler-22b. The 22nd interesting star in a telescope's long list, and the first planet found circling it. For a while, that modest string of letters and numbers carried more human hope than any other name in the sky. It was called a second Earth. It was called Earth 2.0. It was the world, people said, where we could live. The truth about Kepler-22b is stranger and more sobering than the celebration ever suggested, and the story of why is the story we will walk through tonight, slowly, one quiet piece at a time. The claim that made it famous was real, and it is worth stating carefully. Kepler-22b was the first planet ever confirmed to orbit inside the habitable zone of a star similar to our Sun. Every word in that sentence is doing work. Not a dim red star, of the kind that fills the galaxy in enormous numbers, but a star genuinely like ours, golden and steady. Not a scorched world skimming its star's surface, and not a frozen one lost in the outer dark, but a planet resting in the band of distances where water could, under the right conditions, stay liquid. Nothing like it had ever been confirmed before. When the announcement came, it traveled around the world in a day, and the planet's catalogue name appeared in headlines beside pictures of blue oceans and white clouds that no telescope had ever seen. The pictures were paintings. They were always paintings. But they were painted onto something real, and the something real deserves its due before we take the dream apart. The discovery itself was an act of almost absurd patience. A space telescope was sent up with one job, and the job was to stare. It fixed its gaze on a single patch of sky, a region covering roughly 1/400th of the heavens, and it did not blink for years. Inside that one patch lay about 150,000 stars, and the telescope watched all of them at once, continuously, measuring their light with a steadiness no human eye could hold. It was looking for shadows. When a planet happens to pass between its star and us, the star dims by a tiny amount, the way a distant lamp dims when a moth crosses in front of it. The crossing is called a transit, and it is one of the quietest events in all of astronomy. Nothing explodes. Nothing flares. A point of light simply becomes very slightly fainter, holds that faintness for a few hours, and returns to normal, as if nothing had happened at all. For Kepler-22b, the dimming amounted to about 1/20th of 1% of the star's light. Consider what that means for a moment. If the star's light were 1,000 candles, the planet's crossing would blow out half of one of them. noticing that change from 600 light-years away has been compared to watching a flea crawl across a searchlight on the horizon. The telescope noticed. It was built to notice, and it noticed thousands of such shadows in its one patch of sky, each one a candidate world waiting to be confirmed. Confirmation, though, has rules. A single dimming proves very little, because stars flicker for their own reasons. Two dimmings, spaced apart, begin to suggest a rhythm. Three dimmings, arriving on schedule, separated by identical intervals, are the signature of an orbit, a world coming around again and again, like a figure on a carousel. So the telescope had to wait for Kepler-22b to circle its star 3 separate times. And because this planet takes about 290 days to complete one orbit, that patience stretched across nearly 3 years. 3 years of watching one star among 150,000, waiting for a shadow the width of half a candle in 1,000. The third crossing arrived at last in the middle of a holiday season, and the people who found it allowed themselves, briefly, to call it a gift. A quiet planet, wrapped in 3 years of silence, delivered at the end of a long stare. What made the confirmation electric was not any single fact, but the combination of 3. The star was like our sun, slightly smaller, slightly cooler, but unmistakably the same kind of steady golden furnace. The orbit was like our own year, 290 days against our 365, close enough that a calendar there would feel familiar rather than alien. And the temperature, at least on paper, sounded like an invitation. If Kepler-22b had an atmosphere like Earth's, early estimates placed its surface around 22 degrees Celsius. That is not a number that belongs to astronomy. That is a spring afternoon. That is a window left open. Even with no atmosphere at all, the planet's equilibrium temperature worked out to roughly 11 degrees below zero, which is a cold day in a northern winter, not the deep freeze of space. Between those two figures lay every gentle possibility a hopeful mind could want, and hopeful minds wanted them very much. But hidden inside that spring afternoon was an assumption, and the assumption is where our story truly begins. The comfortable temperature was not a measurement. No thermometer has ever touched Kepler-22b, and no instrument has ever read its air. The number was a calculation, and the calculation required someone to choose an atmosphere for the planet, to assume it had one, to assume the atmosphere resembled ours, to assume there was a surface underneath it for the warmth to rest upon. Change any of those assumptions, and the same planet computes out entirely differently. The famous 22 degrees was a hope with decimal places. It was honest work, clearly labeled, but the labels fell off somewhere between the astronomers and the headlines, the way labels tend to do. To understand what was actually promised, it helps to understand what the habitable zone really is, because the phrase carries far more weight in public imagination than it was ever built to hold. The habitable zone means one thing, and one thing only. It is the band of distances from a star where a planet with the right kind of atmosphere could keep liquid water on its surface. Notice how conditional that sentence is. The right kind of atmosphere could keep. If there is a surface, the zone says nothing about whether a given planet actually has water, nothing about whether it has air, nothing about whether it has ground to stand on, and nothing at all about whether anything could live there. It is a statement about distance and starlight, and about nothing else. A planet in the habitable zone is like a house on a pleasant street. The address tells you the neighborhood is mild. It does not tell you whether the house has walls. The zone's popular nickname has done real damage here. It is often called the Goldilocks zone, after the fairy tale, the place where things are not too hot and not too cold, but just right. The name is charming, and the name is quietly misleading, because it smuggles in the idea that being in the zone means being just right. Nothing in the science says that. Our own moon orbits inside the sun's habitable zone, at the same lovely distance we enjoy, and it is a grey, airless, utterly dead world, where the temperature swings by hundreds of degrees between noon and midnight. The address is perfect. The house has no walls at all. Even the edges of our own neighborhood tell the same story. Venus rides near the warm inner boundary of the sun's comfortable band, and Venus is a furnace hot enough to melt lead crushed beneath a sky of acid. Mars sits near the cool outer boundary, and Mars is a rusted desert where the air is too thin to hold a breath or a memory of rain. One neighbor scolded, one neighbor frozen, both of them within reach of the zone's gentle promise. The band of pleasant distances is real, but its edges are not gentle, and residence within it guarantees nothing. It is a first filter, the coarsest sieve in the search for living worlds, and it catches furnaces and deserts and dead grey moons right alongside anything that might truly be mild. And so we arrive at the quiet, unresolved heart of the matter. Kepler-22b passed the first filter, the first world around a sun-like star ever to do so, and the world celebrated as if it had passed the last one. In the years since, it has remained one of the most discussed temperate planets in the entire catalogue, studied, modelled, argued over, painted again and again in blues and whites it may not own. And after all of that attention, its most basic property, the simple question of what it is actually made of, remains unknown. We know how wide it is. We do not know what it weighs. And as we will see, inside that single missing number hide three completely different planets, three possible versions of Kepler-22b, every one of them a world you would not want, each in its own distinct and remarkable way. Tonight we will visit all three. There is no need to hurry toward any of them. They have been waiting 600 years for their light to reach us, and they will wait a little longer while you settle in. Part 2. The star, the orbit, and the light. Before we can understand the planet, we should spend a little time with its star, because everything a world is begins with the light that falls on it. The star is called Kepler-22, and it belongs to the same family as our Sun. Astronomers class it as a G-type star, which is the technical way of saying a middle-sized, middle-aged, golden-white furnace, steady in its burning, and unremarkable in the best possible sense. It is slightly smaller than the Sun, by about 2% in diameter, and slightly cooler, by a few hundred degrees at its surface. Its total output of light comes to roughly 3/4 to 4/5 of what the Sun pours out. If you could stand beneath it, you would almost certainly not notice the difference. Its light would look like sunlight, perhaps a whisper warmer in tone, a faintly deeper gold, the kind of difference you might sense on some quiet level without ever being able to name it. The star sits about 600 light-years from us, in the direction of a northern constellation drawn as a swan, gliding along the band of the Milky Way where the sky grows dense with stars. 600 light-years is a distance worth sitting with for a moment, and we will sit with it properly near the end of tonight's journey. For now, hold just one piece of it. The light from that star arriving at our telescopes tonight did not leave it this year or this century. It left 600 years ago, when the tallest structures human beings had ever built were cathedral spires, when no machine had ever flown and no voice had ever crossed an ocean. That old light is the only material we have ever had to study this system. Everything we know about Kepler-22b, every number in tonight's story, was carried to us by light older than the printing press. Around this calm golden star, the planet traces its orbit at about 85% of the distance between Earth and the Sun. It rides noticeably closer to its star than we ride to ours, and it completes each circuit in about 290 days. A year on Kepler-22b runs some 10 weeks shorter than a year here. As it moves along that path, the planet travels at roughly 30 kilometers every second, which is almost exactly the pace of our own world around the Sun. There is something quietly companionable in that detail. Two planets, 600 light-years apart, sweeping along their separate curves at nearly the same unhurried speed, each one keeping a rhythm the other will never hear. Now comes a piece of arithmetic that sounds harmless and is not. The star is dimmer than ours, which should make the planet colder. The orbit is closer than ours, which should make it warmer. The two effects very nearly cancel, and it is tempting to leave the sentence there, balanced and comfortable. But they do not cancel exactly. When the numbers are worked through, Kepler-22b receives roughly 10% more starlight than Earth receives from the Sun. Not less. More. This planet, so often painted as a cool blue twin of ours, actually leans toward the warm inner edge of its star's habitable zone rather than resting safely in the middle of it. A world with abundant water and a generous share of sunlight is not automatically fortunate. Extra light falling on open water means extra evaporation, and water vapor is itself a heat-trapping gas, a blanket that thickens as the air warms. There is a slow, humid failure that can grow from exactly this arrangement, and later tonight we will see how it works. For now, it is enough to notice that the postcard version of Kepler-22b, the temperate garden world, was drawn for a planet that sits closer to the fire than the postcard ever admitted. If you could stand on some surface there, whatever surface it may or may not have, the sun in its sky would not look quite like ours. The star's disk is nearly the sun's size, but it hangs at a closer distance, and so it would appear larger, about 15% wider than the sun looks from Earth. A slightly bigger sun, a slightly softer gold, hanging in a sky whose color nobody on our world has ever learned. Sunsets there, if the planet turns, would be broader and slower affairs, the wide golden disk taking its time at the horizon. It is one of the few genuinely gentle images this planet offers, and even this one comes with a caution, because a larger, warmer-toned sun delivering 10% more light is precisely the fire we just spoke of, made visible. The geometry of our view adds one more quiet detail. We only found Kepler-22b because its orbit happens to be aligned almost perfectly edge-on to our line of sight. The planet crosses the face of its star, as seen from here, which is the shadow the telescope was built to catch. That alignment cuts both ways. If anyone stood in that system with a telescope as patient as ours, pointed back along the same line, they could watch our own world cross the face of our sun. Earth transits, seen from Kepler-22. Two windows facing each other across 600 light-years, and so far as we know, only one of them has ever had a face at it. Here it is worth pausing to credit the star with the one great mercy in this story. Kepler-22 appears to be a calm star. G-type stars of its kind are steady burners. They do not lash their planets with constant flares, and they do not strip nearby worlds bare with storms of radiation. That is not a small thing. The most common stars in the galaxy, the small red dwarfs, are famous for exactly that violence. Their habitable zones huddle close in, and the planets in those zones sit in the blast radius of every outburst, their atmospheres slowly sandblasted away by their own suns. Many of the temperate worlds in the catalogue orbit stars like that, and their prospects dim accordingly. Kepler-22b, whatever else is true of it, does not live under an angry star. Its sun is patient, steady, and quiet. If this planet is hostile, and it is, the hostility is not the star's doing. The star has, in a sense, done everything right. The star may even outlast ours. It carries slightly less mass than the sun, and stars are strange economists. The less massive they are, the more slowly they spend themselves, and the longer they live. A star just a little lighter than the sun can look forward to a noticeably longer life on the main sequence, the long, stable middle age in which stars are safe to live beside. Whatever Kepler-22b is, it likely has more time ahead of it than our own world does. Time, this system has in abundance. It is nearly everything else that remains in question. And now we come to the things nobody knows, which in the case of this planet is a long and remarkable list, beginning with something as simple as the day. The length of a day on Kepler-22b is completely unmeasured. Nobody knows how fast it turns, or whether its spin is brisk like ours, or slow beyond patience. What we can say is that it is probably not tidally locked. Tidal locking is the fate of worlds that orbit very close to their stars, where gravity's grip slows their rotation over ages, until one face points forever at the fire and the other forever into the dark. The close-in planets of red dwarf stars lock this way within mere millions of years. But locking weakens sharply with distance, and at nearly an Earth-like distance from a Sun-like star, a planet's spin should survive for billions of years. Kepler-22b almost certainly still turns. It almost certainly has sunrises. What no one can tell you is how often they come, or how long the light lingers, or what the morning looks like when it arrives. The same silence covers its seasons. Seasons are made by tilt, the lean of a planet's axis against its orbit, and the tilt of Kepler-22b is unknown. If its axis stands nearly upright, the planet has no seasons at all, only one endless, unchanging climate at every latitude, the same weather repeating until the star itself grows old. If the axis leans the way ours leans, at that gentle angle of ours, it would know something like spring and autumn, a familiar breathing of the year. And if the axis lies far over on its side, the seasons become something else entirely, hemispheres taking turns aiming at the star, each pole swinging between months of unbroken light and months of unbroken night, a climate of slow extremes rolling around the planet with every 290-day year. All three of those worlds are consistent with everything we have measured. They cannot all be real, but tonight, at this distance, they are all still possible, layered over one another like exposures on the same photograph. So this is the setting as honestly as it can be drawn. A calm and generous star, a slightly hurried year, an old slow light 6 centuries deep, and a planet leaning closer to the warmth than its reputation suggests, keeping its days, its seasons, and its weather entirely to itself. None of this, so far, is the trouble with Kepler-22b. These are only the stage and the lighting. The trouble begins with the planet's body itself, with the simple question of how big it is and what that bigness means. Because the single most important number we possess about this world is its width, and the single most important number we lack is its weight, and between those two facts opens a door onto 3 very different planets. It is time to walk through that door, gently, and meet the first of them. Part 3. The world we cannot weigh. Here is the central fact of Kepler-22b, the hinge on which everything else tonight will turn. We know how wide this planet is, with real precision. We do not know what it weighs. Its width comes out to about 2.4 times the width of the Earth, and its mass, the single number that would tell us what this world actually is, has never been measured at all. Sit with that pairing for a moment, because it is stranger than it first sounds. Imagine being handed a wrapped gift and being allowed to measure the box with a ruler as carefully as you like, but never allowed to lift it. A box of that size might hold books or feathers or nothing but air around one small stone. Until you feel its weight, the box holds all of those possibilities at once. Kepler-22b is a wrapped gift the size of 2.5 Earths, and for all the years we have known it, no one has ever managed to lift the box. The reason lies in how each number is obtained. The width came from the transit, the little shadow the planet casts as it crosses its star. The depth of that dimming reveals how large the planet's silhouette is compared to the star's disk, and since the star's size is well understood, the planet's size follows with satisfying accuracy. But a silhouette is only a silhouette. It tells you the outline and nothing about the substance. Weight is measured entirely differently. A planet does not simply circle its star, it also pulls back on it, tugging the star into a tiny wobble as it swings around, and the heavier the planet, the larger the wobble. Astronomers can read that wobble in the star's light, and for thousands of worlds they have done exactly that, weighing planets across unthinkable distances. It is one of the quiet triumphs of the age. But the method has limits, and Kepler-22b sits beyond them. The planet's tug is too gentle, and its star is too far away and too faint for the wobble to rise clearly out of the noise. Careful attempts were made, and they returned not a weight but a ceiling. Kepler-22b can be no heavier than a few dozen Earths. Below that ceiling, the measurements simply cannot see. It is worth being clear that this is a failure of distance, not of method. The same technique weighs planets around nearer, brighter stars as a matter of routine, and had this world orbited a star 50 light-years away instead of 600, we would likely have settled the question long ago. The silence around its mass is not a mystery of the planet. It is simply the tax the distance charges on everything we ask. Notice what that leaves open. A few dozen Earths at the top, and at the bottom, nothing rules out a world light for its size, puffed up like a balloon, less dense than water. Between those limits lies not a range of similar planets, but a family of utterly different ones, worlds that share nothing except their width. Some are balls of rock and iron. Some are drowned globes of warm water. Some are small gas planets with no surface at all. Every one of them, from the outside, at this distance, casts exactly the same shadow. The box measures the same no matter which of them is inside. The width itself makes matters worse, because 2.4 times the size of Earth is a deeply unlucky size to be. It falls in a gap in our experience. Look around our own solar system and count what we have. Earth is the largest of the rocky worlds. The next size up from Earth is Neptune, and Neptune is nearly 4 times Earth's width, a giant wrapped in bottomless blue-gray air. Between Earth and Neptune, our solar system contains nothing. Not one world. No moon, no planet, nothing in between to visit, to photograph, to land on, to learn from. And yet, when the Great Planet Census came back from that patch of watched sky, it revealed that worlds in exactly this in-between size range are among the most common planets in the entire galaxy. The universe's favorite size of planet is a size our solar system forgot to make. We live in the gap. Kepler-22b lives in the middle of it, and we have no local example, no nearby laboratory, nothing we have ever touched to tell us what such a world is like up close. The census did reveal one crucial pattern, though, and it is the best clue we own. When astronomers lined up the thousands of newly found planets by size, they did not spread out smoothly. They split into 2 crowds, with a strange emptiness between them. On one side, worlds smaller than about 1.5 times Earth's width, and these are mostly dense and rocky, true solid planets, larger cousins of our own. On the other side, worlds from about twice Earth's width and up, and these are mostly light for their size, far too light to be rock. They are rocky or icy cores, wrapped in deep envelopes of hydrogen and helium gas, small cousins of Neptune, worlds of thick air and no ground. And between the 2 crowds runs a valley, a size range near 1 3/4 Earth widths, where planets are strangely scarce, as if nature herself disliked lingering there. The valley has an explanation, and it is worth hearing, because it tells us why there are two kinds of world and almost nothing in between. It comes down to hydrogen, the lightest and most abundant gas there is. When planets first form around a young star, the larger ones gather envelopes of hydrogen around themselves, drawn in from the same cloud that built everything else. But young stars are harsh. They pour out fierce ultraviolet light and X-rays for their first stretch of life, and that radiation boils away at the atmospheres of nearby worlds. A planet that holds only a thin coat of hydrogen loses it entirely, stripped down to the bare rock, and lands in the small, dense crowd. A planet that gathered enough gas, or kept enough distance from the fire, holds its envelope, and even a modest envelope swells it dramatically. Hydrogen is an all-or-nothing garment. Either it is torn away completely, or it is kept, and keeping it transforms the world. That is why the middle of the valley stands nearly empty. Half measures do not survive. And here is the detail that matters for our planet tonight. It takes astonishingly little hydrogen to change everything. An envelope amounting to just 1 or 2% of a planet's mass, a rounding error, a trace, is enough to roughly double the world's apparent width. Two planets could be near twins in their rocky hearts, and if one holds a whisper of hydrogen, the other lost, they will look like members of different species. Size, in this range, is not a measure of substance. It is a measure of clothing. So where does Kepler-22b fall? At 2.4 times Earth's width, it sits squarely in the second crowd, well past the valley, deep in the territory of the gas-wrapped worlds. And its orbit makes the clothing easy to keep, because it rides far enough from its calm star that the early radiation would have struggled to strip it. If it ever wore hydrogen, it likely wears it still. Played purely by the statistics then, the most probable Kepler-22b is not a large Earth at all. It is a small Neptune. A world whose surface is not hidden but absent, a world that may have no floor to stand on anywhere. The first planet ever celebrated as a second Earth is, by the honest arithmetic of the census, most likely a world where the word ground does not apply. But statistics are not a verdict. The census speaks in probabilities, and individual worlds are free to be exceptions. The ceiling on the planet's weight still leaves room for every family member. And so the honest picture of Kepler-22b is not one planet but three scenarios, 3 doors, and tonight we will open each in turn. Behind the first door, a massive rocky super-Earth, the biggest possible version of a solid world, and, as we will see, a crushing place to be. Behind the second, an ocean world, a globe wrapped seamlessly in water hundreds of kilometers deep, with no land anywhere at all. Behind the third, the small Neptune, the world with no floor, where you do not land because there is nothing to land on. The remarkable thing, the thing that gives tonight's journey its shape, is that we do not need to guess which door is real to know the character of this planet. Every door leads somewhere hostile. The scenarios simply take turns being hostile in different ways, each one less standable than the last. One last measure before we open the first door, to set the scale of what is at stake. Surface area grows with the square of width, so if Kepler-22b does have a solid face, that face is nearly 6 times the area of Earth's entire surface. 6 Earths worth of ground, or 6 Earths worth of ocean, waiting behind the doors. Whatever this world turns out to be, there is a great deal of it. Density is destiny for planets, the old line goes, rock sinking heavy, water resting lighter, gas lightest of all, and destiny, for Kepler-22b, is exactly what we have never been able to weigh. So we will do what the evidence cannot, and walk through the possibilities one by one, beginning with the version the headlines always wanted. The solid one. The second Earth itself. It is, in some ways, the most unsettling door of the three. Part 4. The crushing super-Earth. Let us open the first door, and let us be generous as we do it. Suppose the optimists were right all along. Suppose Kepler-22b is rock, from its skin to its center, the largest possible version of a solid world, a true super-Earth. This is the planet the celebrations implicitly promised, the one in all the paintings, the world with ground to stand on and skies to look up through. It is the most Earth-like of the three possibilities, and that is precisely what makes it so instructive, because even this most hopeful version turns out to be a world that would break us, slowly and thoroughly, beginning with the simple act of standing up. The trouble is weight. A ball of rock 2.4 times the width of Earth does not weigh 2.4 times as much. Volume grows with the cube of width, and so a rocky Kepler-22b would mass somewhere between roughly 20 and 35 Earths, depending on how much iron sits at its heart. Surface gravity follows from mass and width together, and for the plausible rocky versions of this planet, the answer lands somewhere between 3 and 6 times the pull we live under. Let us be kind, as we have been all along, and take the gentlest figure. 3 times Earth's gravity. 3G, in the shorthand of pilots and engineers. It is a number small enough to sound survivable, and heavy enough to rearrange every hour of a human life. Feel what it means. A person who weighs 70 kilograms here would press down on Kepler-22b with the weight of 210 kilograms. Nothing about their body would have changed, and everything about their existence would have. Every step becomes a lift performed with triple the load. Standing still becomes an act of quiet labor, the muscles of the legs and back working the way they work here when you carry another person on your shoulders. The heart, that patient machine, must push blood up out of the legs and into the head against 3 times the resistance it was built for, every beat, without rest, without night shifts off. Sitting brings little relief, because the body pressing into the chair weighs triple too. Even lying down, the weight does not leave, it only spreads. The chest itself grows heavy, and each breath during sleep lifts ribs that weigh as much as a loaded backpack. On such a world, there is no position, no posture, no hour of the day or night in which your body is not working harder than it has ever worked here. Gravity is the one condition of a planet that no wall, no roof, and no machine can keep outside. You do not visit 3G. You wear it, waking and sleeping, until it wears you down. The small details of daily life turn strange in the same direction. A cup of coffee lifts like a brick. A child weighs like an adult, and an adult like 2. Rain falls harder, drops driven down with triple force, so that a storm stings bare skin. A fall from standing height, the kind of stumble that bruises a hip here, arrives with the energy of a fall from a second-story window, and bones that would crack on Earth shatter there. The floor, on a heavy world, is never far away and never friendly. Simply growing up would be different. Bodies raised under that pull would develop short, dense, thickened skeletons, built low against the strain, and a person shaped by that world who somehow came to Earth would feel our gravity let go of them like a hand releasing its grip. Everything a settlement would try to do there pays the same tax. Every beam raised, every crate moved, every bucket of water carried pays triple, so construction crawls and machines burn through their strength, doing work that would be light here. Flight offers a strange bargain. The thick air we will meet in a moment gives wings far more to push against, so staying aloft is easier than you might guess, but climbing costs triple, and everything carried aloft weighs triple too. The oldest trick for surviving high gravity is water. A body floating in a tank is held up evenly, everywhere at once. its heart finally relieved of the uphill work, and it may be that the only truly comfortable place on a heavy Kepler-22b would be submerged, residents returning to the water again and again the way we return to our beds. Permanent inhabitants might spend most of their lives reclined or afloat, standing only when they must, because on such a world uprightness itself is a luxury spent carefully. The planet itself is shaped by the same pressure and shaped in the same flattening direction. Mountains are a negotiation between the strength of rock and the pull of gravity, and at 3 times our gravity, rock loses the negotiation early. The crust simply cannot hold up tall peaks. They sag and settle and surrender long before they reach the heights our world allows. There would be no soaring ranges on a heavy Kepler-22b, no sharp young summits catching the light. The landscape trends low and wide, endless rolling plains, shallow basins, hills worn down almost as soon as they rise. Erosion helps the flattening along because rivers cut harder when water falls heavier, and landslides trigger sooner when slopes carry triple load. Even the planet as a whole gives in, rounding itself toward an almost perfect sphere, tolerating none of the slight bulges and flattenings that lighter, faster worlds can afford. It is a world ironed smooth by its own weight, a geography with the drama pressed out of it. Above that low landscape sits the sky, and the sky is heavy too. Gravity this strong holds air fiercely, and a rocky Kepler-22b would very likely wear a dense, deep atmosphere, with surface pressures far beyond what we know at sea level. Air that thick changes the very texture of experience. Sunlight arrives scattered and diffused, the shadows soft and grey, the wide golden sun of this system reduced at ground level to a pale glow spread across the whole ceiling of cloud. Wind in air that dense is no longer quite wind as we know it. A moderate breeze carries momentum closer to that of moving water, and a storm becomes something you would describe less like weather and more like a tide. And the thick blanket thins quickly as you climb, because strong gravity squeezes the atmosphere into a shallow layer, its pressure falling away fast with altitude. Even the low, humbled hills of this world would poke into noticeably thinner air. The livable sky, like everything else here, is compressed toward the ground. Stranger things happen below the surface. The interior of a super-Earth is not simply Earth's interior scaled up. Pressure changes the rules. Deep inside such a world, the rock of the mantle is squeezed until it flows far more stiffly than ours does, and many models of these planets arrive at the same quiet conclusion: the outer shell seizes. Instead of Earth's mosaic of drifting plates, jostling and diving and remaking the surface, a heavy world's crust may lock into a single unbroken lid of rock, a planet wearing one continuous shell. Deeper still, the mantle may hold exotic forms of mineral that exist nowhere inside our own planet, changing how heat finds its way out. And a stagnant lid does not mean a silent world. The heat of the interior must still escape, and where it cannot leak steadily through moving plates, it gathers and punches through in concentrated plumes. Picture a flat grey land under a flat grey sky, punctuated at great intervals by volcanic provinces of enormous size and patience, built over ages in one place because the lid above them never moves. That locked lid sounds like a geological footnote. It is closer to a sentence passed on the whole planet, because plate tectonics on our world is not scenery. It is the thermostat. Earth's moving plates run a slow cycle that draws carbon out of the air, buries it in rock, and breathes it back out through volcanoes over millions of years. A feedback that has caught our climate every time it stumbled, warming the world out of its frozen ages and cooling it down from its fevers. A planet without that cycle has no such hand on the dial. Its climate is free to drift and lurch, to freeze hard and stay frozen, or to heat and keep heating, with nothing built in to call it back. And the stillness may reach deeper yet. A sluggish interior may fail to stir the molten iron of the core, and a core that does not churn cannot generate a magnetic field. Without that shield, the stellar wind, even from a calm and gentle star, sandblasts the top of the atmosphere over the ages, and radiation from the wider galaxy falls to the ground unfiltered. The very mass that gives this world its crushing grip may also leave it unshielded and unregulated, heavy on the outside and still on the inside. So here is the first Kepler-22b, the best case, the solid one, the second Earth itself. A world of grey, diffuse light and flattened horizons, of air like a warm ocean and weight that never once lets go, standing unshielded under its patient golden star. It is livable, perhaps, in the narrowest sense of that word, for machines and for the most stubborn kinds of life. It could hold ponds and seas and chemistry. Nothing forbids it. But for anything shaped like us, it is a world experienced entirely as burden, and we have not yet mentioned its cruelest feature. That feature is not what the planet does to your body. It is what the planet does to your future, and it deserves a door of its own. Part 5. The Gravity Prison. There is a number attached to every world that most people never think about, and it decides more about that world's future than almost any other. It is called escape velocity, and it is the speed at which a thing must travel to climb out of a planet's gravity entirely and never fall back. For Earth, the number is about 11 kilometers per second, some 40,000 kilometers per hour. Everything humanity has ever sent beyond our sky, every probe drifting past the outer planets, every machine now coasting into the space between the stars, had to reach that speed, or a good portion of it, and reaching it is the single most expensive thing our species does. It is worth remembering as we settle into this part of the night that the whole of our presence in space hangs on that one number being just barely affordable. On a rocky Kepler-22b, the number is not affordable. A world of 20 to 35 Earth masses squeezed into 2.4 Earth widths holds its possessions with a ferocious grip, and its escape velocity works out to somewhere between 2 and 4 times our own. 22 to 45 kilometers per second, where we pay 11. At first hearing, that sounds like a harder version of a familiar problem, the way a taller mountain is a harder version of a climb. It is not. It is a different kind of problem entirely, and the reason lies in the strange, unforgiving arithmetic of rockets. A rocket is a machine that carries its own push. Everything it will ever throw out behind itself to move forward must be lifted along with it, and there is the trap, because the fuel needed to reach a given speed must itself be carried, and carrying it requires more fuel, and that fuel requires more still. The relationship is not a straight line. It is exponential, which is a mathematician's way of saying that each small increase in the speed you need multiplies, rather than adds to, the machine you must build. Our own rockets, built for our own modest 11 kilometers per second, already sit at the edge of what chemistry allows. The great launch vehicles of our world are more than 90% fuel by weight at the moment they leave the ground. The gleaming towers on our launch pads are, by mass, almost entirely their own propellant, thin metal skins wrapped around the cost of leaving. We do not so much launch payloads as launch fuel, with a whisper of cargo riding on top. That is what escaping one Earth gravity demands. That is the price at the bottom rung of the ladder. Now raise the required speed by double, and the exponential does its quiet work. The fraction of the rocket that can be anything other than fuel shrinks brutally, toward almost nothing. A chemical rocket built to escape such a world directly would need to be so nearly all propellant that its structure, its tanks, its engines and its cargo must fit inside a sliver of the total. Engineers speak of such designs the way sailors speak of impossible weather. And at 3 times Earth's escape velocity, the honest number for the heavier versions of a rocky Kepler-22b, the sliver closes entirely. The equation still returns an answer, but the answer is a rocket that is 100% fuel, which is to say, no rocket at all. Chemistry itself gives out. The energy stored in molecular bonds, the same energy that lifts our machines, is simply not concentrated enough to climb that well. It does not matter how clever the engineers are or how large the budget grows. On a heavy super-Earth, the sky is not merely expensive. Within any technology resembling rocketry as we know it, the sky is closed. Let yourself feel what that would mean, not for a visitor, but for anyone native to such a place. Imagine a civilization arising on a heavy Kepler-22b, minds as curious as ours, growing up under that wide golden sun. They could do so much of what we have done. They could learn the laws of falling bodies and the mathematics of orbits. Where their thick sky allowed glimpses, or where their instruments learned to listen in other kinds of light, they could map their galaxy from the ground, discover their own catalogue of distant planets, work out, from the wobbles of stars, that lighter worlds than theirs exist. They could calculate exactly what leaving would require. That may be the quietest cruelty of all. Nothing would stop them from understanding their situation completely. Their scientists could stand at a chalkboard and derive, in an afternoon, the same exponential we just walked through, and see with perfect clarity that the universe above them was visible and priced beyond reach. Astronomy would be, for them, a window in a locked room. They would know the stars precisely as well as anyone can know a thing they will never touch. For such a people there would be no satellites, and so no view of their own world from above, no weather eyes in orbit, no machines relaying voices around the curve of the planet, none of the quiet orbital infrastructure our world takes for granted. Their moon, if they had one, would remain a light in the sky forever, a destination in mathematics only. Perhaps they would find other ways upward in imagination, balloons rising through the heavy air, gliders riding thick winds that carry like water. The air would lift them generously, higher and higher, and then hold them there, kilometers short of space, at the ceiling of a well they could see out of but never leave. Every generation could climb to that ceiling and look up at the unreachable stars through the thinning grey, and every generation would come back down. It is fair to ask whether cleverness could find a way around the rocket, because our own engineers have imagined alternatives for centuries. Each of the famous loopholes closes on a heavy world, one by one, and it is quietly instructive to watch them close. The great cannon, firing its cargo skyward in a single push, fails twice over. The required speed is higher, and the dense atmosphere we met earlier stands above the muzzle like a wall of water, burning and shredding anything driven through it at such velocity. The space elevator, that lovely dream of a cable lowered from orbit down to the ground, is a contest between the strength of materials and the weight of the cable itself. And it is a contest our own gravity already nearly wins. No material we know can quite manage the task even here. Triple the gravity, and the demand on the cable multiplies beyond anything chemistry's bonds can offer, the dream snapping under its own arithmetic. Even the exotic proposals, beams of light pushing sails, ladders of machines climbing on power sent from the ground, all inherit the same tax, because every route out of a gravity well must, by one accounting or another, pay the same energy bill, and the bill on a heavy super-Earth is not 3 times ours but closer to 6, paid against air 3 times as thick. The well does not care how the climb is attempted. It prices every path the same, and the price is the whole treasury. There is a wider thought resting here, and the channel has brushed against it before, on an evening spent with the great silence between the stars. The galaxy's census tells us that worlds larger than Earth are among the most common kind. If even a fraction of them are heavy, rocky worlds, then scattered across the galaxy there may be many civilizations in exactly this position, intelligent, curious, fully aware of the universe around them, and permanently grounded by nothing more sinister than arithmetic. Some of the silence we hear when we listen to the sky may simply be this: minds like ours, sealed under heavy skies, unable to send anything upward, calling out, if they call at all, only in whatever light can leak through their thick grey air. It is not a frightening answer. It is a strangely tender one. The universe may hold many windows and few doors, and it casts our own situation in a light worth pausing on. Earth, it turns out, sits near the top of the range of worlds from which chemical rockets can leave at all. Had our planet been modestly larger, a half again our width with the weight to match, the exponential would have closed over us the way it closes over Kepler-22b, and all our longing for space would have remained exactly that. We speak often on this channel of the ways our world is gentle. Here is one almost never mentioned. Earth is small enough to leave. The door out of our sky is heavy, and it opens. We happen to be born on one of the rare worlds where the arithmetic just barely says yes. So closes the first door on the most hopeful version of Kepler-22b, and it is worth a last look back before we move on. A solid world, yes, with real ground and real seas, the second Earth of every painting. And with it, gravity that triples every burden, land ironed flat, skies of permanent grey, a locked crust with no thermostat, quite possibly no magnetic shield, and above it all, a ceiling no ambition could ever break. If this is Kepler-22b, it is a world that would take our bodies in a generation and our descendants' hopes forever. And yet, remarkably, the story can get stranger. Behind the second door, the rock gives way to water, endless and shoreless and deep beyond reason, and the trouble stops being weight and becomes hunger. Let us drop the assumption of rock, gently, and let the water rise. Part 6. The Endless Ocean. We have come a fair distance already tonight, so before the second door opens, let the pieces settle back into place for a moment. There is a planet, 600 light-years away, that was the first world ever confirmed in the habitable zone of a star like our Sun, and it was celebrated as a second Earth. Its star is calm and golden, and slightly smaller than ours, and the planet circles it every 290 days, drinking in about 10% more light than Earth receives. We know the planet's width, 2.4 Earths across, and we have never once managed to weigh it, and inside that missing number hide 3 different worlds. We have visited the first, the rocky super-Earth, and found a flattened land of triple weight and grey skies, a planet that crushes its residents and then, through the cold arithmetic of escape velocity, refuses to ever let them go. That door is closed now. You can let it go with it. The second version of Kepler-22b asks nothing of your shoulders or your spine. Its trouble is of an entirely different kind, and it begins with water. Suppose the planet's density falls in the middle range between rock and gas, which many careful readings of the evidence consider quite plausible. A world like that is not built like ours. A substantial fraction of its entire mass, perhaps 1 part in 10, perhaps as much as half, is water. It helps to understand how alien that proportion truly is, because Earth, whatever the photographs from orbit suggest, is not a water world. Our planet is a rock that happens to be damp. All the oceans of Earth together, every sea, every gulf, all of it, amounts to about 1/50th of 1% of the planet's mass. If Earth were the size of an apple, its oceans would not even be the skin, they would be a breath of moisture on the skin. Kepler-22b, in this second scenario, is what the phrase ocean world actually means, when it is meant literally, a globe whose outer layers are water, through and through, wrapped seamlessly around a distant rocky heart. Water in that quantity does not make seas. It makes a single sea with no other side. The ocean of this Kepler-22b would run hundreds of kilometers deep, plausibly more than 1,000, and it would cover everything, absolutely everything, without exception. It is worth being slow and literal about what that means. There is no land. Not modest continents, not islands, not an archipelago, not a reef, not one rock parting one wave anywhere on a sphere holding 6 times the surface area of Earth. The deepest point of our own oceans lies 11 kilometers down. Sink that entire trench into this world's sea, and it would be a dimple near the surface, the first 100th of the way to the bottom. Every mountain our planet ever raised would drown here without a trace. Take the tallest of them, stack it on its own twin, then again and again dozens of times over, and the pile would still stand nowhere near air. This is not an ocean in any sense we have lived beside. It is a layer of the planet itself, the way our world has a crust, and it happens to be made of water. An ocean without shores behaves strangely, in ways both gentle and terrible, and it is honest to give the gentleness its due first. Water is the great steadier of climates. It warms slowly, cools slowly, and holds its temperature the way stone holds the day's heat into the evening. A world entirely wrapped in deep water would know the mildest swings of any planet imaginable. Days barely warmer than nights, summers barely different from winters, the whole globe cushioned in thermal patience. And with no large moon ever found beside this planet, there would be little tide to speak of, no twice-daily breathing of the sea against the land, and of course no land for it to breathe against. Taken purely as water and weather on a calm day, this may be the most peaceful scenario in the whole catalogue. A warm, still, shoreless sea beneath the wide golden sun, grey-blue to every horizon, and every horizon identical. But stay with the picture a little longer, and the strangeness begins to press in. On Earth, every wave eventually finds a coastline, somewhere to spend itself and end. Here, a wave has nowhere to arrive. Swells raised by the wind can travel around the entire planet and meet themselves, crossing and recrossing forever through other waves doing the same, an interference pattern the size of a world, never fully spending what the wind gave them. And the wind gives generously, because storms on a shoreless ocean are missing the one thing that kills storms on our world. A hurricane, here at home, is an engine that runs on warm, open water and dies when it crosses land, starved of its fuel. On this Kepler-22b, there is no land to cross, ever. A great storm, once organized over that warm and generous sea, can simply keep going, wandering the globe for weeks or months, feeding without limit, a continent of rotating wind, circling a planet that offers it no reason to stop. Between storms, the mildest weather imaginable. Within one, a violence with no natural end. The deeper strangeness, though, is not meteorological. It is what shorelessness does to possibility. Think of how much of Earth's story, the story of life and then the story of minds, happened at edges. Tide pools, riverbanks, mudflats, coasts, the places where water meets rock and both meet air, where chemistry is stirred and concentrated and challenged. This world has no edges at all, only one boundary, the flat meeting of sea and sky, identical everywhere across 6 Earths of surface. And consider one deceptively small consequence, one this channel finds almost impossible to stop thinking about. On a world with no land, there can be no fire. Nothing to burn, and nowhere dry to burn it. Suppose, against every obstacle, some intelligence one day arose in that sea, curious and capable, the whale minds or squid minds of a far shore we will never chart. Every road we followed out of our own long night runs through flame, cooking, pottery, smelted metal, glass, engines, and at last, the machines that lifted us off the planet. For a mind in a shoreless ocean, that entire highway simply does not exist. No forge can be lit underwater. No ore can even be reached, as we will see behind the next door, because this ocean is sealed away from its own rock in a way our oceans never were. Such minds might build with bone and current and song, might develop mathematics, memory, culture, all of it carried in water, and none of it able to strike a single spark. The gravity prison of the last door locked its people under a heavy sky. This door builds a gentler prison out of wetness itself, and its inmates would never even see the bars. There is a subtler disorientation waiting on such a world, one that reveals itself the moment you imagine trying to say where you are. On Earth, every position is ultimately anchored to land. Our maps, our borders, our addresses, even our names for the seas themselves are drawn against coastlines. On a shoreless ocean, there is nothing to anchor to, no fixed point anywhere on the surface, nothing that stays. Water moves, and everything on it moves with the water. A place you named yesterday is not there today. It has drifted with the current, dissolved into the general motion, and the spot it occupied is indistinguishable from every other spot on a globe of identical horizons. The only fixed references such a world offers are overhead, the patient stars and the wide golden sun, and position becomes something you calculate rather than something you recognize. No one on this Kepler-22b could ever go home in the way we mean it. They could only return to coordinates, to an abstraction, to a set of angles measured against the sky, and find whatever had drifted through it in their absence. Home, on the endless ocean, is not a place. It is an act of navigation, renewed forever. Seen from orbit, this Kepler-22b might show none of its nature. A deep, warm ocean under generous sunlight breathes vapor upward, and vapor becomes cloud, and a water world may well wrap itself in an unbroken shell of white, a featureless pearl hanging in the dark, its endless sea never once directly visible from space. That shell of cloud would matter too in the planet's ledger of heat, because white cloud throws sunlight back before it can warm the water, and a world that veils itself completely cools itself in the veiling. How much cloud, and how much cooling, no model can say from here. The pearl keeps its accounts to itself. The painted blue marble of the announcement posters and the truth beneath the paint could be a planet that never shows its face. Even its inner structure would be hidden strangeness, a sea that deep may settle into layers that never mix, fresher water riding above briny depths, strata of different salts and pressures stacked like geology, an ocean with its own buried oceans inside it. And all of this, remember, is still the kind scenario. Nothing so far in this water world crushes you or poisons you. The surface, on a calm day, might even be lovely. The trouble with the endless ocean is not at its surface. The trouble is below, far below, where the water meets something that is neither water nor rock, and where this gentlest version of Kepler-22b quietly starves. It is time to descend. Part 7. The Floor of Hot Ice. Let us leave the surface now and sink. The descent begins gently. In the first 100 meters, the water of this endless ocean would still be daylight water, gold-green and alive with drifting light from that generous sun. But light and water are old adversaries, and water always wins. Sunlight, entering the sea, is absorbed and scattered a little more with every meter, the reds surrendering first, then the greens, then the last deep blues, and within a few hundred meters of the surface, on this world as on ours, the light is gone. Not dimmed, gone. Everything below that shallow sunlit skin lies in a darkness that has never once been interrupted, on a world where below is almost all there is. It is worth trying, gently, to take in the size of that dark. On Earth, the lightless deep sea is already the largest habitat the planet has, dwarfing every forest and plain. But our oceans average only a few kilometers of depth. This ocean plunges hundreds of kilometers, perhaps more than 1,000, over a surface 6 times the area of Earth's. Run the arithmetic through, and the dark water of this one planet could exceed the volume of all Earth's oceans combined, not by a factor of 10 or 100, but by many hundreds of times. One world, holding within itself hundreds of Earth's worth of midnight sea, a black interior ocean larger than every drop of water our entire solar system's inner worlds have ever held, descending silently beneath that bright and gentle surface. And at the bottom of it waits one of the strangest objects planetary science has ever had to imagine. Because the descent does not end in rock. Follow the water down, and the pressure climbs with every kilometer, the weight of everything above pressing on everything below. 10 kilometers down, the pressure already exceeds anything our submarines endure. 100 kilometers down, it has passed anything our engineering has ever touched. And somewhere in the depths, at a few hundred kilometers, the pressure crosses a threshold where water itself gives up a freedom we assume is its nature. The molecules, crowded past all resistance, can no longer tumble and slide past one another. They snap into place. They order themselves into a crystal. The water freezes, and it freezes not because it is cold, but because it is crushed. This is one of those places where the universe simply declines to match our intuitions. We learned as children that ice is what cold makes, and that heat is its undoing. But the ice at the floor of this ocean is a different substance in all but name, a family of dense crystal forms that exist only under immense pressure, arrangements of water molecules packed tighter than ordinary ice could ever manage. Physicists number these forms like chapters, and the deep chapters hold a property that sounds like a contradiction spoken aloud. They remain solid while hot. Ice, at the bottom of a world like this one, can sit at temperatures approaching those of an oven, hundreds of degrees, glowing with heat by any human measure, and remain rigidly, permanently frozen because the weight of 1,000 kilometers of ocean allows the molecules no room to melt. Hot ice is not a poetic flourish. It is a plain description of pressure-frozen water, and on an ocean world Kepler-22b, it forms the entire floor of the sea, a shell of hot, glass-like, luminously alien crystal, possibly hundreds of kilometers thick, wrapped around the whole planet beneath the dark. And that shell changes everything, because of one consequence so simple it can be said in 6 words: the water never touches the rock. Between the deepest drop of ocean and the first surface of stone lies that unbroken lid of dense ice, sealing one away from the other across the entire face of the world. On Earth, we barely think about the meeting of water and rock, and yet nearly everything alive depends on it. Our continents weather in the rain, and the rain carries their minerals to the sea, an endless slow delivery of the raw materials of biology. Our seafloors split and vent, pumping hot, mineral-rich water into the deep, feeding whole ecosystems that never see the sun. Rock is where the ingredients are. Water is where the chemistry happens. Life, as our world practices it, is the conversation between the two. The endless ocean of Kepler-22b may be a conversation with one voice missing, water everywhere and rock forever out of reach, the pantry locked below the kitchen with no stair between them. Our own solar system, as it happens, offers a small and haunting preview of this arrangement. The great icy moons of the outer planets hide oceans of liquid water beneath their frozen crusts, kept warm by the flexing of tides, and they are rightly counted among the most promising places to seek life near home. But the largest of them carries a complication that planetary scientists discuss in careful tones. Its ocean is deep enough that pressure may do there, in miniature, exactly what it does on our imagined Kepler-22b, freeze the bottom of the sea from below. Such a moon's water would be sandwiched between two shells of ice, ordinary cold ice above, dense pressure ice beneath, sealed away from its rock on both sides. The smaller icy moons, whose oceans are shallower, may rest their water directly on stone, and that single difference, the touch of water on rock, is a large part of why some of those little worlds excite biologists more than moons far larger. The lesson scales. In oceans, depth is not generosity. Past a certain point, every added kilometer of water is another turn of the key in the lock, and the endless ocean of Kepler-22b, hundreds of times deeper than any of these moons could dream, is locked as thoroughly as water can be. Follow that scarcity to its sharpest point, and you arrive at a single element: phosphorus. Of all the ingredients in the recipe of life as we know it, the backbone of its molecules of inheritance, the currency of its energy, phosphorus is the scarcest and the least replaceable, and it enters Earth's oceans almost entirely by the weathering of exposed rock. A sealed ocean has no exposed rock. Whatever phosphorus was dissolved in it during the planet's chaotic youth is all it may ever have, a fixed inheritance, spent slowly across the ages and never renewed. Some models do offer thin lifelines. The deep ice, warmed from below, may convect over long ages, creeping upward and carrying faint traces of what it once touched. The shell's margins may leak. But these are trickles where Earth enjoys rivers. An ocean fed that way does not starve outright. It lives, if it lives at all, on a starvation diet, its every possible ecosystem rationed down to the thinnest broth. And so we reach one of the strangest conclusions in all of tonight's journey. The kindest version of Kepler-22b, the temperate, shoreless sea, may be a paradise with nothing in it. Thousands of kilometers of clean, warm, perfectly habitable water, in the precise technical sense of habitable, temperature right, pressure survivable through enormous volumes, chemistry unhostile, and nearly empty, because habitability is not the same as food, and a world can pass every test of livability and still set no table. Astronomers sometimes speak of water worlds with a kind of reverence, and it is deserved. But an honest reverence includes this: the most livable Kepler-22b may be the loneliest object in this whole story, an ocean the size of hundreds of Earths, waiting with every door open and no one able to be born in it. The sealed floor plays one more trick, and this one touches the sky. Recall the thermostat we spoke of behind the first door, the slow cycle by which our planet's rock breathes in carbon dioxide, buries it and breathes it back, steadying the climate across millions of years. That cycle needs exposed, weathering rock, and this world has none. Whatever carbon dioxide finds its way into the ocean world's atmosphere has no drain, no slow burial, no mechanism of forgetting. It simply accumulates, century upon century. Now set that fact beside the other one we have been carrying since early tonight. This planet receives roughly 10% more starlight than Earth. A warm, shoreless ocean, evaporating freely under a generous sun, wrapped in air whose greenhouse gases can rise but never fall, is a world leaning toward a particular kind of slow failure, the moist greenhouse, in which warmth breeds vapor and vapor breeds warmth, patiently, with no thermostat anywhere to interrupt the spiral. It would not happen in a year or a millennium, but the gentlest Kepler-22b carries the seed of it, a quiet instability folded into all that stillness, and nothing on the planet is equipped to dig the seed out. Down at the true bottom, where the dark water finally rests on the hot ice, the pressure reaches tens of thousands of times the air pressure you are lying in now. No light has ever touched that boundary. No sound from the surface reaches it. If you could stand there, shielded by impossible engineering, your lamp would be the first light in the history of that place, falling on a smooth, pale floor of scalding crystal that stretches, unbroken, around an entire world. That is the foundation of the gentle scenario. That is what the kindest Kepler-22b is standing on. And the last door of the three now waits, with the strangest offer of all, because behind it, even this floor is taken away. Part 8. The world with no floor. And so we come to the third door, and honesty requires us to say it plainly before we open it. Of the three possible planets we have visited tonight, this is the one the evidence favors. The census of worlds, with its two crowds and its empty valley, places Kepler-22b deep in the territory of the gas-wrapped planets. Its orbit is far enough from its young star's early fury that any hydrogen it gathered, it likely kept. Played by the honest arithmetic, the most probable Kepler-22b is not a heavy Earth and not an endless ocean, but a small Neptune, a mini-Neptune in the astronomer's plain phrase. If that is what it is, then the first planet ever celebrated as a second Earth does not have a surface. Let the sentence arrive slowly, because it is the strangest one of the night. There is no ground. There is no floor, no seabed, no crust, no place anywhere on the planet where falling stops and standing starts. On such a world, the word on loses its meaning. There is no on. There is only in. Its anatomy, as far as understanding can reach, would run like this. Somewhere at the center, a core of rock and ice, perhaps the size of Earth, perhaps larger, a buried world that might have been a planet in its own right, had history dealt it different cards. And wrapped around that core, an envelope of hydrogen and helium, the two lightest gases there are, amounting to no more than a few % of the planet's total mass. Remember how little that is, and how much it does. A trace of hydrogen, a rounding error in the planet's ledger, is enough to swell its silhouette to the 2.4 Earth widths we measure, enough to move it from one family of worlds into another, enough to erase the very concept of a surface. The core never sees the sky. The sky never reaches the core. Between them stretches the whole substance of the planet, thickening by degrees, and nowhere in all that depth is there a line where one thing ends and another begins. Suppose you descended into it, riding some vessel of impossible patience. The first hours would be almost serene. High in the envelope, the air is cold, thin and clear, hydrogen faintly hazed, and the wide golden sun of this system would light the cloud tops below you the way evening light falls on a field of snow. There would be cloud decks of water ice up here, white and layered and soft-edged, and if you knew no better, you might mistake the scene for the top of a gentler world's weather waiting to receive you. Even the color overhead would be subtly wrong. Hydrogen scatters light in its own way, and the high sky of such a world would likely wash toward a pale blue-white, thinner and colder in tone than Earth's deep blue, a sky like watered milk over the golden cloud fields. It would be beautiful, in the way unfamiliar things seen briefly are beautiful. It would also be the last honest beauty of the descent. As you sink, the sky begins its long, seamless betrayal. The pressure climbs, gently at first, then insistently. The light thins and warms in color as the hydrogen above you deepens, gold sliding toward amber, amber toward a heavy brown dusk. The temperature, cold where you began, rises steadily as the gas compresses beneath everything pressing from above. You pass the warmth of a summer day. You pass the boiling point of water. The last brown light dies around you, and you continue downward in absolute dark, instruments alone reporting the world outside, hotter than any oven now, pressure beyond every submarine, and rising, always rising. Somewhere far below, the temperature passes the melting point of lead, while the darkness stays perfect. And still there is no floor. There is only the thickening. That thickening deserves a moment of its own, because it is one of the strangest textures the universe offers. On Earth, air is air and sea is sea, and between them lies that clean line sailors and swimmers know. Descend far enough into a world like this, and no such line ever comes. The hydrogen around you simply grows denser, crowding from gas towards something with the heft of liquid, without ever pausing at a boundary to announce the change, fog becoming soup by degrees too fine to name. If deep layers of water exist down there, the water fares no better. At such pressures and temperatures, water becomes a supercritical fluid, a state that is neither liquid nor steam, denser than mist and hotter than any kettle, with no surface where one condition hands over to the other. A world of transitions without edges. You could fall through it for the rest of any lifetime and never once arrive. Nothing stops your descent but the crush itself, the depth at which the density outside finally matches whatever your vessel is, and there you would hang, entombed in black pressure, at a place that is not a place, having landed on nothing. The weather of such a world runs on its own logic, and the logic never rests. Our own two ice giants, the small gas worlds nearest in kind to this one, carry winds measured at up to 2,000 kilometers per hour, among the fastest in the solar system, on worlds that receive only a whisper of sunlight. The engine is not the star, it is the absence of ground. On Earth, every wind is slowly bled of its energy by friction against the surface, every storm ground down by the land it crosses. A world with no surface offers no friction worth the name, and so its jets, once set running, simply run, permanent rivers of wind circling the globe for ages, and its storms can live for centuries, immense organized ovals of weather, with lifespans longer than nations. Deeper still, the pressure works stranger transformations. Water compressed into ionic and superionic states, its molecules partly torn apart, arranged into forms that conduct electricity like molten metal. Currents in those buried layers can drive a magnetic field of great strength, and a strong field gathers radiation belts around the planet and pours auroras over its poles, sheets of silent light at the top of that bottomless sky, grander perhaps than anything Earth's gentle field has ever drawn. A blind world, decorated in lights no one may ever see. Even here, science holds a candle of optimism, and it deserves honest mention. Planetary scientists have imagined a best-case version of exactly this kind of world and given it a name, the Hycean planet, a marriage of hydrogen and ocean. If the envelope is thin enough and the depths arrange themselves kindly, the bottom of that hydrogen sky might rest on a genuinely liquid, planet-wide ocean, kept warm by the gas blanket above it, and temperate sub-Neptunes elsewhere in the catalogue are being searched, right now, for signs of that arrangement. It is a real possibility, and for simple life, a genuinely interesting one. But notice what the best case amounts to for anything like us. That ocean lies beneath hundreds to thousands of atmospheres of pressure, under a sky of unbreathable hydrogen, in a gloom deeper than any twilight, and its water may sit near the temperature of a kettle just before the whistle. Beneath it, at depth, the same hot pressure ice floor we met behind the second door seals away the rock with all the starvation that entails. A womb for microbes, conceivably. A home for nothing that breathes. The kindest reading of the most probable Kepler-22b is a warm, dark, crushing nursery that could never once be visited by its admirers. And here the story of the famous temperature completes its long, quiet irony. The 22 degrees that traveled around our world, the spring afternoon, the open window, was always a statement about a surface, and the most probable Kepler-22b has no surface for it to describe. What that planet has instead is a level, an altitude somewhere in its endless sky, where the thermometer, and only the thermometer, would read like home. Ride there in your vessel, and the instruments would report a perfect mildness, while outside the window there is nothing but poison gas in amber gloom, tens of thousands of kilometers of crush yawning below, and no ground anywhere in the world. The most Earth-like place on Kepler-22b is not a place at all. It is a temperature hanging in a bottomless sky, an address with no house, no street, and no land beneath it, all the way down. Nor will time repair any of this. At this planet's distance from its calm star, a hydrogen envelope, once kept, is kept for good. The gentle stellar wind lacks the fury to strip it, and billions of years from now this world, if this is its nature, will still be what it is tonight, thickening quietly under its golden sun. Even the science fiction escape fails here, and it fails with a certain dark elegance. Dreamers have long imagined floating cities in the skies of gas worlds, but a balloon rises only when filled with something lighter than the air around it, and in a hydrogen sky there is almost nothing lighter to fill it with. The lightest gas in the universe is the one you are drowning in. So the third door closes, and with it the tour of the 3 planets, the Crusher, the Drowner, and this one, the world that is all sky. What remains is what the 3 have in common, and it is time we gathered it up. Part 9. Everything Earth quietly does. 3 doors, 3 planets, and every one of them hostile in its own patient way. But suppose, for the sake of this part of the night, that we grant Kepler-22b every benefit of every doubt. Suppose it threads all the needles at once, solid ground but merciful gravity, water but also land, air but not too much of it, the impossible lucky version that the paintings always showed. Even then, even for that planet, the phrase habitable zone would be checking exactly 1 box on a form that runs for pages. Because a world is not made livable by its distance from a star. It is made livable by machinery, a whole hidden apparatus of stabilizers and shields and slow correcting cycles. And the deepest lesson of Kepler-22b is how much of that machinery Earth runs silently, beneath our notice, every day of our lives. So let us walk the checklist now, item by item, and watch how each one comes back unknown, or missing, or already failed, for the most famous temperate planet in the sky. Begin with the moon, of all things. It is easy to think of our moon as scenery, a lamp for poets and a friend for the sleepless. It is also the reason Earth's climate has a spine. Our planet leans as it orbits, and that lean, that axial tilt, gives us our mild and reliable seasons. But the lean itself needs holding. A planet's axis is not fixed by anything sacred. It is tugged endlessly by the gravity of its sun and its neighboring worlds, and left alone, those tugs can accumulate into chaos. Earth is not left alone. Our abnormally large moon rides beside us like a hand steadying a spinning top, and because of it, Earth's tilt wobbles only about a degree either way across great stretches of time. That stability is why our ice ages were survivable dips rather than extinction-grade flips, why the poles have stayed roughly the poles, why a forest can stand in one climate for 10 million years. We know what the alternative looks like because it orbits next door. Mars, with no meaningful moon to steady it, is believed to have swung its tilt by tens of degrees across the ages, tipping so far that ice which now caps its poles may once have girdled its equator. On a world like that, no climate is ever permanent. The very direction of north slowly falls over. Searches were made for a moon around Kepler-22b, patient ones, combing the transit light for the small additional shadow a companion would cast. None was found, none large enough to see. That is not proof of absence, but it is permission for the worst case. A Kepler-22b with a solid surface and no stabilizing partner could be a world whose axis wanders chaotically across millions of years. A planet where the poles migrate to the equator and the equator freezes, where every ecosystem that ever establishes itself is eventually dismantled by the sky itself, not through any catastrophe, but through the slow, total reorganization of what sunlight falls where. Nothing about the habitable zone forbids it. The address stays perfect while the house slowly rolls over. Next on the checklist, the shield. Earth's molten iron core churns like a slow kettle, and that churning generates the magnetic field, the invisible armor that turns the stellar wind aside around us. Without it, a star, even a calm and gentle star, erodes a planet. The wind of charged particles pouring off a sun slowly sandblasts the top of an unshielded atmosphere, stripping it away atom by atom across the ages, and it took the air, and with it the water, of a whole world within our own view. Mars, again, small, unshielded once its field failed, and now a rusted vacuum where rivers used to run. Whether Kepler-22b carries armor of its own is unknown, and here the irony of the three doors sharpens to a point. The heavy super-Earth, the most standable version, is the one whose core may be locked solid by pressure, unable to churn, unable to shield. The ocean world wraps whatever core it has beneath hundreds of kilometers of ice and water, insulating it towards stillness. Only the mini Neptune, the version with no surface at all, is likely to generate a mighty field from its strange conducting depths. The one version of Kepler-22b that is probably well shielded is the one with nothing underneath the shield to stand on. The armor goes to the world that cannot use it. Then the thermostat, which we have already watched fail twice tonight. Earth's slow carbon cycle, rock weathering in the rain, carbon buried at sea, volcanoes breathing it back, has caught our climate every time it stumbled for 4 billion years. The locked lid of the super-Earth has no moving plates to run that cycle. The shoreless ocean has no exposed rock to weather. 2 doors out of 3 open onto worlds with no hand on the dial, free to freeze hard and stay frozen, or to warm and keep warming, with nothing built in to call them home. The 3rd door opens onto a world where the concept of surface climate does not even apply. 3 versions of the most celebrated temperate planet in history, and not one of them can be shown to own a working thermostat. And after the big machinery come the smaller dials, the ones that would decide what daily life even means there, every one of them unread. The length of its day unmeasured, and free to be anything from a brisk 8 hours to a crawl of 800, and the difference is not cosmetic. A fast-spinning world stirs its air into many small weather cells and keeps its temperature contrasts modest. A slow roaster develops scorching afternoons that last for weeks, nights that fall like a season, and winds reorganized into slow, planet-scale rivers of air. The lean of its axis, unknown, as we heard earlier, anything from no seasons at all to hemispheres taking turns at roast and freeze. The shape of its orbit only loosely constrained, and a modestly stretched orbit would swing the planet closer to and farther from its fire each year, running the whole world through an annual fever and chill regardless of tilt, a climate with a pulse. Each of these dials, on Earth, happens to rest at a gentle setting. Each one, on Kepler-22b, is a spinner that has never been read, and any of them alone could be the difference between a mild world and a maddening one. It is true that a sufficiently thick atmosphere can paper over some of these failures, and it is worth pausing on that consolation just long enough to see its price. Air in great quantity is a formidable equalizer. Wrap a planet in a deep enough blanket, and the difference between noon and midnight nearly vanishes. The winds carry warmth from the dayside around into the longest night, and even a chaotic tilt or a crawling rotation can be smoothed into something climate-like. Our own scalded neighbor demonstrates the trick. It turns so slowly that a single one of its days outlasts its year, and yet its surface temperature barely varies from equator to pole, from noon to the depth of night, because its enormous ocean of air evens everything. But look at what the fix costs. An atmosphere thick enough to iron out a broken rotation is an atmosphere thick enough to crush, to smother, to hold heat like a sealed oven, and thick enough that no one standing beneath it would ever see a star. The sky itself becomes a ceiling. On a world healed by that medicine, the universe disappears. The nights are blank, the sun is a vague brightness in a permanent overcast, and astronomy, the art that connects a world to everything beyond it, may never have a reason to be born. The cure for a missing moon and a wandering axis, it turns out, is a lifetime of never once seeing the night sky. Earth, with its thin and improbable air, gets the mild climate and the stars. That combination, our combination, is the one the checklist almost never grants. But the blankest entry on the whole checklist, the one that quietly governs all the others, is the air itself. We do not know what Kepler-22b's atmosphere is made of. Not partially, not roughly, at all. And it cannot be overstated how completely that one blank swallows every temperature, every painting, every hopeful sentence ever published about this planet. The famous 22 degrees assumed an Earth-like blanket of air. Thicken the blanket, and the same planet at the same distance computes out as a furnace. Thin it, and the same numbers deliver a frozen wasteland. Change its chemistry, and all bets simply leave the table. Our own neighborhood proves the stakes. At nearly the same distance from the same sun, one wrapped world melts lead, and one bare world holds its breath forever. Distance did not decide between them. Air did. And the air of Kepler-22b is a page with nothing written on it, because its star is too faint and too far for any instrument of this era to read the planet's atmosphere during its transits. The tools that are, even now, reading the skies of nearer worlds fall silent at 600 light-years. The blank will stay blank for a long time to come, and every confident picture of this planet is a picture painted over that blank. Step back then, and look at what the checklist has told us, because this is the true heart of tonight's story. A large moon of the right size, holding the tilt. A churning core, holding the shield. Moving plates and weathering rock, holding the thermostat. A gentle day, a gentle lean, a nearly circular orbit, an atmosphere of exactly the right weight and recipe. Earth passes every item on that list so quietly that it took our species most of its history to notice the list existed. Kepler-22b, item by item, returns unknown, unknown, missing, failed. Not because it is a cursed or unusual world, but because passing the whole list at once is the rare thing, the almost absurdly rare thing, and the habitable zone was only ever the first line of the form. Hold that thought gently, because it is really a thought about home, and we will return to it before the night ends. But first, having spent so long with charts and machinery, let us do the simplest and strangest thing of all. Let us go there, in the only way anyone ever will, and spend one human day on Kepler-22b. Part 10, A Human Day, on Kepler-22b. Every fact we have gathered tonight has been seen from a distance, the view through 600 light-years of telescope glass. For this part of the night, let the distance close. Imagine that the impossible journey has somehow been made, that a small human settlement clings to whichever Kepler-22b turned out to be real, and walk through a single ordinary day there. Not a day of disaster or discovery. Just a day. It is in the ordinary days that a world tells you what it really is. Begin on the heavy world, the rocky super-Earth, since it is the only version with ground in any familiar sense. You wake before the alarm, because sleeping at 3 times Earth's gravity is shallow work. Your own chest is a weight you have lifted all night, breath by breath, and your body keeps a light grip on wakefulness, the way it does here at altitude. Getting up is a decision made twice, once in the mind and once in the legs. Outside the window, the morning is bright and utterly shadowless. The wide golden sun of this system diffused by kilometers of dense air into a ceiling of pale glare, and the land runs low and flat to a far horizon, hills pressed down by their own weight long before anyone came. The settlement's paths are short by design. Nothing on a 3G world is far from anything else, because every meter is carried. You do your work in the morning, when your strength is freshest, much of it lying back or waist-deep in the flotation pools where the pull finally, briefly, lets go of your heart. In the afternoon you rest, as everyone rests. And in the evening, perhaps, you climb, everyone does it once in a while, up the settlement's low rise to look at the sky through the grey, knowing what every child here is eventually told, that this is as high as anyone goes. The stars above this world are a view from the bottom of a well, and the well was measured long ago, and the answer was no. Now let the same day happen on the water, on the endless ocean. Here you wake to motion, the long, patient swell of a sea that has never in its history touched land, rocking the platform on which everything you own and everyone you know is floating. The morning is warm and close, the horizon a perfect unbroken circle. The same circle in every direction, the same circle every day of your life. There is no smell of earth here, no dust, no stone. The air carries only water, and the settlement's own metals and greenhouse green. Your work is the work everyone shares, tending the tanks where every calorie is grown from starter stock the founders carried, checking the drift, reading the weather. Always reading the weather, because the sea that feeds nothing also forgets nothing. And somewhere over the curve of the world, always, a storm that has never crossed land is feeding and wandering, and once or twice a year the platforms must seal themselves and sink beneath the surface to let one pass, down into the calm that begins a few dozen meters under the waves. That is the strangest part of this life to describe to anyone who has not lived it. Safety here lies downward, into the dark, and the community rides out the howling weeks below, in the stillness, waiting for the ocean's permission to come back up. The children have a game they play on the anchor days, naming what land might have been like. Mountain, cave, beach. They say the words the way our children say the names of dragons. And on the third world, the most probable world, the day happens in the sky, because there is nowhere else for it to happen. You wake in an aerostat, a lifted habitat riding the one narrow altitude where the thermometer reads like home, a shelf of mildness a few kilometers thick in a sky 100 kilometers deep. Above the canopy, the light is a pale gold filtered through cloud decks of ice. Below the floor, an amber gloom thickens away into a darkness that has no bottom, only more pressure, only deeper night. The great jets carry you around the planet on their own schedule, and your settlement's position is not a place but a drift, plotted daily against the stars when the high haze allows. The outside air is hydrogen, unbreathable, and every generation is taught the same catechism the founders wrote. A failure here is not a crash. There is nothing to crash into. A failure here is a descent, slow or fast, into heat and crush. And so the aerostat's buoyancy cells are checked the way other worlds' children are taught to check the weather, daily, reflexively, forever. Life at the mild level is, in its way, gentle. The temperature is kind. The light is soft. And every soul aboard lives with the knowledge, worn smooth as a stone in the pocket, that the kindness is one altitude thick, hung in a sky that goes down and down beneath the floorboards, all the way to nowhere. There is one more thing the 3 days would share, and it works in the body itself, in the slow language of generations. Settlement anywhere is one way in fuel and distance, but on Kepler-22b, it becomes one way in flesh. On the heavy world, The children grow short and broad and immensely strong, their skeletons laid down dense against the triple pull, their hearts enlarged like athletes' hearts from birth, and by the third generation they are a people built for their planet and quietly unfit for the old one. Set them down on Earth, and the ground would seem to release them, every step too high, every object too light, their own strength abruptly absurd. On the ocean, the drift works on the mind instead. Children raised on the platforms swim before they walk, read weather the way our children read faces, and carry no instinct at all for solid ground, for distances that stay where you left them, for the very idea of a place that does not move. And in the amber sky of the third world, the aerostat generations inherit a horizon that is always below them, a species of vertigo in reverse, at ease above a bottomless deep and uneasy at the thought, described in the old books, of ground pressing up against one's feet. Within a century, on any version of the planet, the settlement is no longer a colony of Earth. It is a people of Kepler-22b, shaped by it, native to its weight or its water or its winds, and the world that sent them has become what this planet once was to us, a story told at bedtime about somewhere no one they know will ever stand. 3 settlements, 3 utterly different days, and yet notice how much they share, because what they share belongs to the planet itself, to every version of it. On all 3 worlds, the sun overhead is a shade larger and a shade more golden than the one you were born under, and it crosses the sky on its own unhurried schedule through a year of 290 days, so every calendar brought from home has quietly stopped meaning anything. The settlers keep 2 dates, the local and the ancestral, the way emigrants keep 2 languages. On all 3 worlds the nights are truly dark, because no moon has ever been found here. There is no silver lamp to rise over the water or the plains, only starlight, and the stars themselves are subtly wrong, the constellations redrawn by 600 light-years of displacement, familiar patterns pulled apart into shapes with no names yet. Some of the settlers still search that unfamiliar sky on clear nights, with charts and patience, for one particular faint star in the direction the founders recorded. It is not a bright star. From here, the sun is nothing special, one modest point among thousands, easily missed. Everything that ever happened before the landing, every city, every language, every person who ever lived and died at home, is contained tonight in that one pale dot, and you can cover it with your thumb. And there is a stranger comfort available to that thumb-covered star, for anyone there who cares to think it through. The light arriving from the sun tonight, on any version of Kepler-22b, left home 600 years ago. A settler with a fine enough telescope would not be looking at Earth as it is, but at Earth as it was, 6 centuries deep in its own past. The light of the founders' departure, the actual photons of their farewell, would still be en route, crawling across the gulf behind them, due to arrive and shine, faintly, on their descendants centuries after everyone who remembered the leaving was gone. On Kepler-22b, home is not only far away. Home is long ago, and its history arrives like slow mail, the old light of finished events falling steadily out of the unfamiliar constellations. And on all 3 worlds, the deepest shared condition is the silence. Not an eerie silence, only an absolute one. A message sent home tonight travels for 600 years before anyone hears it, and the kindest possible answer travels 600 more. Ask a question as a young settler, and the reply arrives, at the very soonest, 12 centuries later, addressed to descendants 60 generations removed who may not remember why it was asked. There is no call for help that means anything here, no resupply, no visitor, no news that is not already 6 centuries old on arrival. Whatever happens on Kepler-22b, in any of its versions, is handled by whoever is standing there when it happens, with whatever they have, alone in a completeness no human community has ever actually known. Our species has always had a horizon to send for help beyond. This world's horizon sends back only starlight. That is the true texture of a human day on Kepler-22b, beneath the weight or the weather or the amber gloom, the quiet understanding, shared by every settler on every version of the planet, that the nearest human hand not already in the settlement is 600 light-years away. How far that really is, in numbers a sleeping mind can hold, is the last piece of the story, and it is waiting for us now. Part 11. 600 light-years of no. We have saved the simplest fact for last, and it is the one that settles everything else. Even if Kepler-22b were paradise, even if every door we opened tonight had revealed gardens, it would not matter in any practical human sense, because we cannot go. Not cannot as in difficult, or cannot as in expensive. Cannot as in the numbers themselves close the subject, quietly and completely, and it is worth hearing them once in full, slowly, in the dark. 600 light-years is about 5.7 quadrillion kilometers. That is a 5 and a 7 followed by 14 more digits, a number with no honest place in human experience. So build it in steps, the way distance is best carried at this hour. The fastest object our species has ever made is a small probe that fell close past the Sun and was whipped to nearly 700,000 kilometers per hour, a speed that would cross from the Earth to the Moon in about half an hour. Hold that speed forever, aim it at Kepler-22b, and the journey takes roughly 1,000,000 years. 1,000,000. The machines now leaving our solar system, the little travelers moving at a more ordinary 17 kilometers each second, would need more than 10 million. Our species, in its entire anatomically modern form, has existed for about a third of that time. The journey outlasts not the travelers, but the species that sent them. And the dreamed-of solution, the generation ship, a sealed world crawling along at 1% of the speed of light, a pace far beyond anything we can actually engineer, still takes 60,000 years, which is 3,000 human generations born, raised, grown old and buried inside a metal corridor, so that strangers unimaginably removed from the departure might arrive at a world their bodies, as we have seen tonight, may not even be able to stand upon. Physics does allow faster, in principle, and then presents its bill, the energy to push even a single ton to a respectable fraction of light speed exceeds the yearly output of our entire civilization. Nothing forbids the trip. Everything declines to pay for it. And the strangest part is that 600 light-years is, by the galaxy's accounting, nearby. Our Milky Way spans 100,000 light-years. On a map of it, Kepler-22b and Earth sit in the same small neighborhood, 2 grains in the same handful. Shrink the scale until the Sun is a marble in one city, and this planet's star is a marble on another continent, and both marbles are still deep inside a single galaxy among billions. Kepler-22b is the next-door neighbor we can never visit. Even conversation fails at this range. The stray broadcasts of our world, the old signals wandering outward, fade into the galaxy's static within a few tens of light-years. Only a deliberate, aimed, powerful beacon could cross 600, and any exchange would run 12 centuries around. And if something there looked back at us tonight through a patient telescope, it would not see us. It would see our world's light from 600 years ago, a planet of sailing ships and plagues, with no radio, no electric light, no hint anywhere on its dark night side that anyone here had ever found the sky. Between these two worlds, the present tense does not exist. It is fair to wonder, then, why this planet of all planets became the famous one, and the answer says more about us than about it. For years after the announcement, Kepler-22b was the default answer to a question people love to ask: name a planet we could move to. It appeared in lists and documentaries and daydreams, always wearing its painted oceans, a misunderstanding 600 light-years deep and apparently indestructible. Meanwhile, the actual search moved on and moved closer. Within just 50 light-years of Earth lie more than 1,000 star systems, and the census suggests dozens of temperate worlds among them, worlds whose light is bright enough here for our newest instruments to begin, cautiously, reading their air. If humanity ever does stand beneath another sun, it will be one of those nearby suns, a neighbor of the neighborhood, not this distant celebrity. And the telescope that started it all has its own gentle epilogue. It stared until the fine control that steadied its gaze wore out, was cleverly coaxed into a second career, scanning new fields with the pressure of sunlight itself, helping to hold it steady, and then, its fuel finally spent, was retired into a quiet orbit around the sun, where it drifts still. Its catalogue keeps yielding discoveries years after its eyes closed, planets found in old data by new patients. And there is something fitting in that, an instrument built to watch one patch of sky for years, still teaching from memory, long after the watching is done. So what, then, was Kepler-22b, if it was never somewhere to go? Here, at the end, the story asks to be turned over gently, like a stone that has been lying face down all night, because the promise was never broken. It was misread. The planet was announced as a destination, and it was always a data point, and as a data point, it is one of the quiet triumphs of our lifetime. It was the very first temperate world confirmed around a star like ours, the proof that the arrangement we live in, a mild planet beside a golden sun, happens more than once. The telescope that found it, staring at its single patch of sky, 1/400th of the heavens, pulled thousands of worlds out of that darkness, and the census built on them now suggests that roughly 1 in 5 stars like our Sun keeps a roughly Earth-sized planet in or near its temperate zone. Hundreds of millions of such worlds in this one galaxy, plausibly more. Every one of those tally marks stands in a line that begins at Kepler-22b. Closer, kinder candidates have long since taken its crown, worlds whose air our instruments can actually hope to read, and that is the ordinary way of science. The first of anything is rarely the best of it, and is honored anyway. The first is the one that proves the door exists. And honesty, having taken so much from this planet tonight, should give one thing back. Every version of Kepler-22b is hostile to us, and one of them is not necessarily hostile to life. The endless ocean, or the warm Hycean sea beneath its hydrogen sky, is a place where simple living chemistry is not absurd, and the same facts that make it a terrible home make it a legitimate candidate for a kind of living world Earth has never shown us. Life with no land, no fire, no metal, no view of the stars. Life that never looks up, drifting in a dark, warm immensity, needing nothing from us, not even our belief in it. If that ocean is inhabited, it is inhabited without ambition and without astronomy, and it will never know it was once called a second Earth by a species it will never meet. There is something almost restful in that. The universe does not require our participation to be full, which brings the night, at last, back to where you are lying. Because the real gift of 600 light-years of hostile scenarios is what they reveal, by contrast, about the room you are in. Tonight we have toured worlds that crush, worlds that starve, worlds with no floor at all, and every one of them sits in a habitable zone. Now count, one more time, what you are resting on. A planet with a moon the right size, holding its tilt steady so the seasons keep their promises. A core that churns, raising a shield over your sleep against the wind from the sky. Rock that touches water, feeding the sea that fed everything you have ever eaten. Air thin enough to show you the stars and thick enough to breathe. Gravity gentle enough to rise against each morning, and gentle enough, just barely, to leave. Earth is not the default setting of the universe. The census has made that plain. Earth is the strange one, the world that passes every test the others fail, and you were born on it, and you are lying on it now, and nothing about tonight requires anything of you but rest. And so we leave Kepler-22b exactly where it has always been, 600 light-years away, circling its calm golden star, keeping the secret of what kind of world it is. Whatever the answer turns out to be, it was never waiting for us, and Earth, with its steady tilt and its faithful moon, and its gravity you can rise against each morning, remains the rarest kind of place the search has ever found. You are already home. Let your breathing slow. Let the distance hold everything else. Sleep well and good night.